Welcome to the third lecture of Psych 320, Introduction to Industrial Organizational Psychology. So where we've been the last two lectures, we talked generally about IO psychology, the history of IO psychology, what is IO psychology, industrial organizational psychology, and also what it looks like and the type of people that work and what it looks like to be an IO psychologist. So I've been kind of talking about the importance of the scientific method, and as we move forward into this set of lectures, what we're going to be focusing on is kind of a brief review of the methods and statistics that are used in IO psychology. So the science practitioner model is a key part of what makes IO psychology a unique field. The idea of this strong focus on combining both scientific methodology and research methodology with actual practice in organizations. So as such, there's a strong focus in the training of IO psychology on methods and statistics, but also in this class, we're going to occasionally be drawing from various studies. And I kind of want to talk about the research methods that are used and also some of these core statistical techniques that we're going to be talking about, or I'm going to be referring to through the rest of this class. So, characteristics of the scientific method. The idea behind the scientific method is the concept that there is certain assumptions that we want to start with and that we want to basically take as a given. So any attempt to know about our world is going to have some assumptions. From a philosophical viewpoint, the first assumption most of us make is that there is an actual reality, that there is a world. It's a common kind of philosophy 101 thought experiment to basically have someone try to prove that they're not just a brain in a box somewhere and that all of this is being generated through some kind of artificial reality. So the first assumption that we often make when trying to know the world is that there is a world to know. Now, different ways to know the world make different assumptions. The scientific methodology makes two broad assumptions. Once those assumptions are on the table, everything else is more of a method based on those assumptions. So our two assumptions are empiricism, or empirical, and determinism, or deterministic. Empiricism, being empirical, so you may have heard the term an empirical study or empirical research. Basically what that means is that the best way to know the world is through direct observation. If you want to know at what temperature water boils, you should observe and measure temperature and make experiments. Basically, see if water boils at 200 degrees. Does it boil at 210, 220, 230? So if you really want to know the answer to something, the best way to do is to observe it. Determinism is the other assumption being made, and that is that it's kind of a package deal of our scientific understanding that we accept that there is a reality, but not only that that reality is objective and discoverable. So determinism means that there is cause and effect in the world, the universe, and in every day-to-day encounter. And that though sometimes those causes and effects may be very, very complex, that everything that happens for a reason. So discoverable means through observation we can find these causes and effects, and objective means that they are discoverable and agreeable on. We can look and all agree, this is what's happened in this situation, and this supports our scientific theories. Now, beyond this idea of empiricism and determinism, the next step of the scientific method is the idea of systematic and controlled observation. So it's taking it another step. So the first two bullet points, empiricism and determinism, is about the assumptions that we're making, that we live in a cause and effect, logical and ordered universe, and that the best way to learn about that universe is through direct observation. After that, the rest of these bullet points are more about the methodology that we're going to use to know the world based on those assumptions. So controlled and systematic is a driving force behind almost everything industrial organizational psychologists do. If we're testing something, we want to test it in a very controlled environment. And the reason for that controlled environment is, generally speaking, if you're wanting to determine a cause and effect, you need to make sure that there's very little else that's going on in the situation. So, for instance, if you were trying to figure out what temperature water boiled, if you were trying to boil the water next to a volcano, that volcano would be a really weird experiment to do that, but again, it would be hard for you to know exactly what temperature you were generating with whatever device you were using to heat the water, because there's additional heat sources. So that's kind of a broad example, but the idea again is that if you really want to be able to say this temperature causes water to boil when nothing else is occurring, you want to be in a very controlled environment. You don't want other sources of heat. You want to be able to say the only heat that was applied to this water was the heat that I controlled. And when that heat got to this temperature level, that's when the water boiled. The systematic aspect is that if you're going to make observations, you should make those observations under a set of rules. And those rules can be set up by the researcher or by the practitioner. But it basically says, I'm going to adjust this to where I'm going to run this experiment or this observation over and over again, but I'm going to do it in a systematic way. Every time I do it, I'm going to do it in the same manner. So, beyond being controlled and systematic in the way we make observations, we also want to generate theories and test hypotheses. So theories are broad, logical statements about how we expect the world to work. So again, under the assumption that the best way to know the world is through observation, and the world is deterministic, a theory, for instance, could be that high job satisfaction leads to lower turnover, leaving organizations, and more productivity. Well, that's a theory. That's a theory of job satisfaction. That is a theory that suggests that job satisfaction is important to those other variables, turnover and productivity. Once we have a theory, we then come up with testable hypotheses. So a testable hypothesis might be, let's measure job satisfaction in individuals and find out if those with high job satisfaction are more likely to stay with a company, and those with low job satisfaction are more likely to leave a company. That would start, if we found that effect, that would create basically support for our hypothesis. And that support of the hypothesis would then support our theory. So the theories are generally broad logical statements. Hypotheses are specific, testable questions. And how we test them is through controlled observation. Now, the scientific method will occasionally result in bad data. Just by the nature of things, sometimes you haven't controlled everything. There's an error in your study. Something happens outside of the study that affects it, that makes you think that you found an effect when you haven't found that effect. However, one of the advantages of the scientific method is that the scientific method also assumes that you should never take for granted what other people have studied. In other words, there's a strong component of basically all studies should be repeatable. In other words, they should be done in such a way and described in such a way that other researchers, if they question the data, could run the experiment themselves. And through this method, we kind of have that scientific methodology is self-correcting. So there have been times when science is wrong. But what's cool about science is that when it is wrong, it usually isn't that hard to prove it and find out that it's wrong. It's also subject to public inspection, communicatable, so the entire goal of the scientist and the scientist practitioner model is to not only do research, but to disseminate it through conferences, through presentations, through working in organizations, and through publications, which allows other people to see the theories and the hypotheses they tested, look at their data, and see if they agree with it, and if they don't, they could rerun the study themselves. Again, self-correcting. And finally, the scientific method has some broad aims, and there's 4 of them. Explain, understand, predict, and control. Explaining is just descriptive. So often the first thing that we want to do in any scientific study is just observe. So if you're really interested in job satisfaction and no one's done a study on job satisfaction before, you first need to define what is job satisfaction. And then once you define it, you may just want to observe people and organizations to find out, is your concept of job satisfaction really how they're viewing job satisfaction? Next is to understand it. So understanding is starting to look for relationships. So just basically looking to see, is job satisfaction related to other forms of satisfaction? Are people that have high job satisfaction just overall happier? Are they more healthy? Are they more likely to be loyal to an organization? Once we find those patterns, we can now start trying to predict. So we can say, we found in the past that those with high job satisfaction have higher productivity. Therefore, we would predict our top performers would also be those with higher job satisfaction. And finally, the last thing science aims to do is control. And by control, what we're talking about here is actively intervening in the environment based on the previous studies. So once we've explained a phenomenon, what is job satisfaction? Once we've understood what job satisfaction is, these are factors that it's related to. It seems like we have a good idea of what this actually is and the relationships it has with other constructs or other variables. We can now use job satisfaction to predict future behavior in people. And finally, let's move to control. What can we do to increase job satisfaction to get all of these really great payouts? So broadly, there's two ways to basically look at how theories are used in IO psychology. The first one is the inductive method. The inductive method is basically a method that you use to make sure that you're starting from basically a baseline. So we often will find the inductive method is being used when we're looking at a brand new phenomenon, when we're kind of trying to determine if maybe there's some new construct we should be measuring in the workplace, or there's something that we're interested in that no one's really looked at before. In that case, we're probably going to start with just observations. We're just going to look and watch the behavior. We're going to try to quantify it. We're going to try to measure it. And we're going to organize that information to look for patterns. And from those patterns, we're going to start to form tentative hypotheses. Now, it's important to say we might do some testing at this point, but we're really not talking about the same thing as a testable hypothesis. These are more of just kind of going, well, what patterns would we expect to see with these relatable variables? So again, just using job satisfaction, an inductive method of job satisfaction, if you were wanting to measure it and no one had really looked at job satisfaction before, the first thing you'd want to do is make observations and start taking notes of how do people behave when they seem satisfied with their jobs. You'd start looking for patterns. Is there relationships between job satisfaction and other factors in the workplace? You might start some tentative hypotheses. It looks like people that have job satisfaction generally are happier overall, and we know that people that are happier overall are also usually more accepting of their position in organizations, and also often healthier. And from that, you generate a theory. So in the inductive method, really at its core is the idea that you're going to use observations to generate a theory in the first place. So it's literally going from real-world observations, looking for patterns, starting to think about hypotheses that explain those patterns, and from those generating a broad logical theory. The second scientific method that is often used, and this is more often used, especially in IO psychology, is the deductive method. This is where you start with a pre-existing theory, and there's a lot of theories out there already on how organizations work. There's leadership theories, there's motivational theories, there's groups and teams theories. So you start with a theory, and then you create specific hypotheses which you test with observations in order to confirm the theory and the hypotheses. So you select an area of inquiry. I'm going to research job satisfaction. You're going to advance a tentative hypothesis. Based on my previous observations or other people's observations, previous research, I believe that job satisfaction is also going to be related to counter workplace behaviors. I then go to observations. I get access into an organization. I measure everyone in that organization for their job satisfaction levels. And then I measure how often they're doing counterproductive work behaviors. If I find a strong relationship, I have confirmation or support for my original hypotheses, which also supports the actual theory. So we collect data relevant to our specific questions, and then we test those hypotheses with data. And this is the deductive method. So just some additional terminology. When we're talking about research studies, the independent variable and the dependent variable is what they're often referred to when we're talking about research methods. In IO psychology, because almost always we're talking about application to real-world settings and organizational settings, actual work, jobs, and careers, we often use different terms. So we often refer to the independent variables as predictors, because almost always when we're doing studies in IO psychology, what we're manipulating or what we're measuring to begin with is usually being used to predict an organizational outcome. And that organizational outcome is the dependent variable, and we refer to it as the criteria. And the criteria really represents the concept that our outcomes are all objective, measurable examples of organizational goals. So A criteria can be performance. A criteria can be amount of money made. A criteria can be total number of absences. Our dependent variables are goal-centered concepts that are important to the organization's goal. Now, when we're doing studies, not only are we worried about the independent variable and the dependent variable, and in a true experimental study, that's all that we would have. We'd have an independent variable that we were in control of, that we were changing, and then we'd have a dependent variable that we were expecting to find a cause and effect relationship with. A confound refers to a variable that we're either aware of or maybe even unaware of that can influence the findings of our study. So let me give you an example. A very simple study could be you're simply wanting to look at the effects of music on productivity. So you choose two very different types of music. You've got Slayer, heavy metal, death metal, and you've got Lady Gaga pop music. You bring 100 people into a very controlled lab setting with two exactly the same rooms. The rooms are the same, they're in the same building, no differences in color, there really is nothing differing between those rooms. You take those 100 people and you randomly assign them to either go into the room where Slayer will be played or the room which Lady Gaga will be played. And then you give them a task and you measure performance. If you find a difference in performance between those two rooms, you have evidence that your hypothesis that music matters on performance. That would be using an independent variable, the music, and the dependent variable, performance. A confound would be, as you're running your study, if in one of those rooms also the heating suddenly went out and the room got very, very cold. Now you've got a confound. It's an extraneous variable. You're trying to say that music caused a change in productivity, but something else changed between those two rooms as well, the temperature of the room. So even if you found a difference, you could no longer state music caused a difference in performance. You'd have to say, I think music caused a difference in performance, but it also could have been this confound of temperature change. So once we run a study, we're also worried about the truthfulness of that study, and we're worried about it broadly in two terms. We're worried about internal validity, which is basically, did you have truthfulness within your study? So internal refers to inside your research study. Validity refers to truthfulness or accuracy. So did you manipulate what you think you manipulated? So if you're saying I manipulated music, then did you actually manipulate music? And sometimes that's a very easy question to answer. When you're talking about performance, you're saying that music affected performance. Well, how did you measure performance? If you measure just accuracy on a test, an argument could be made, your internal validity might be a little weak. Maybe all you affected was accuracy, and maybe that's not a great measure of performance. Also, if you have a confound in your study, that is a major threat to internal validity. If you've got strong internal validity, you can then make an argument for external validity. External validity is basically how well we can generalize our findings to other populations, other settings, other conditions, and other outcomes. So if we ran our Slayer versus Lady Gaga performance study at SIUE in Edwardsville, Illinois in the year 2014, with 100 college students. External validity is how reasonable would it be to assume that you would find the same results in a larger population? How reasonable is it that you would find it in other college students? How about 10-year-olds? How about 40-year-olds? How common also as far as this, that's the population. As far as other settings, would you find it at other universities? Would you find it in organizations? Would you find it in institutes? Other conditions. So if you change that independent variable, so it was still music, but it wasn't specifically Slayer and Lady Gaga. So would you find the same effects with Metallica and Katy Perry? And finally, other outcomes. So if music does affect performance as you measured it, in this case accuracy, would it also increase productivity on building things? Would it increase productivity on number of units created? Would it increase productivity on motivation? So those are all different ways to look at the study. So if you're really wanting to say, broadly, music can influence performance, music covers a large number of possibilities, and performance can be measured in many, many ways. So generally speaking, we're very careful using the scientific method to actually make claims beyond the internal validity of the study. So the study that I've been using as my kind of poor example of a research study, If you did find support for it, there were no confounds, you would have to be very careful in what you said you'd find. You'd probably want to say very specifically, we found that the alteration of a very fast-driving, loud, and angry type of music compared to a more contemporary pop type of music had a result on the accuracy of performance in a laboratory setting. And then we'd basically make an argument, this may generalize to other populations, other settings, and other conditions, and other outcomes, but yet, as so far, we don't know if it does. And the way that we find out if it does is to run additional studies. So a lot of studies that are done are actually replications checking for external validity. So as I said, control in research is very important. An experimental control is the idea that we're going to try to control any influence that would make the results less reliable or harder to interpret. And we want to eliminate any of those influences. So those influences are confounds. So experimental control is the idea that in order to really be able to have solid internal validity, we're certain that what we did has only one possible explanation to the results that we found. That's experimental control. Now, a subfactor of experimental control is mundane versus experimental realism. Mundane realism refers to your experiment is actually happening in a way that really resembles the real world. So mundane realism is very important to IO psychology. We're trying to do research about what happens in actual organizations. So whenever you're doing research where you're bringing people into a research lab at a university, that doesn't have a lot of mundane realism. Mundane realism is actually studying people in their workplace while they do their work. Experimental realism is the idea of at least trying to get people to get engaged in the study. So creating interesting studies. So if you're doing a study on performance and you're having people do a task in a lab setting, if you set it up to where they're highly motivated to succeed, maybe they're competing for a prize, maybe they're told that their performance will actually be rated and certain people will be rewarded for how well they do, that would provide experimental realism. Then you could make the argument, well, I know I didn't actually do an experiment in a real-world organization, but my participants were performing as if they would have been in a real-world organization. We can also use statistical control to get to this control. So experimental control is when we set up the actual methodology or what we're doing in a study to make sure that there's no confounds. Statistical control is what is often used in real-world settings. So like I said, that one of the only ways you can make sure there is absolutely no confounds is through a true experiment. Bringing people into a lab setting, having complete control of everything in that experiment except for the one thing that you're wanting to change, and then to look to see how it affects whatever you're measuring. Well, that's almost impossible to do in a real-world setting, in an organization, in a company, in a factory. So statistical control is a technique used to control for the influence of certain variables. So if we're worried about the differences between employees between the night shift and the day shift, we can measure those differences before we run an experiment, and then statistically we can average out those differences before we actually conduct our study. So two methods to try to get more control in experiments. Generally speaking, when we can, IO psychologists do try to do true experiments using experimental control, but a lot of IO psychology research is being done in real-world organizations, which means a lot of times we're using the statistical control. So, there's three basic types of research design, and they're really defined mainly by the use of control. So, experimental, quasi-experimental, and non-experimental. And each one has differing levels of control. So, an experimental design is very high in control, but it's also very specific. It is a very controlled and artificial setting. So the cost of all that control is it's hard to generalize. So in other words, the experimental method has the highest level of internal validity, but it actually tends to have the lowest level of external validity. So you can be very confident that what you find in a true experiment is accurate. There is no other explanation for it. But it's hard to generalize what you find in a lab setting to a real-world work organization. Quasi-experimental designs generally still have some control. They might be using statistical control to try to average out confounds, but there's not going to be as much control. So it's kind of a good middle ground. We have a lot of external validity, but we also have some internal validity and some external validity. So there's problems with both of them in this case. It's kind of a best of both worlds, but neither of them great. And finally, we have non-experimental designs. Absolutely no control. A lot of times, non-experimental designs, people don't even realize they're in a study. So you have very high external validity. If anyone would ever argue, well, that's not how people would behave because they knew they were being experimented on, in a non-experimental design, they most likely don't know they were even a part of an experiment. This is often just observational studies. This is sometimes looking at archival data. But the problem is you have no control. So a true experiment has a few factors, and the most important one is random assignment. The idea that you're going to randomly assign individuals to each of the conditions that you're interested in studying. So going back to my very simplistic music study, random assignment means each person that showed up to that study, a coin would be flipped, and they would end up either in the Slayer or Lady Gaga condition. So the controlled conditions can happen in the laboratory, and they can happen in a field. You can go into an organization and sometimes get the ability to use random assignment. And if we have random assignment and complete control, so we're in complete control of the experiment, we have made sure there's no other possible variables that are occurring between our groups that we're creating, and those groups are being randomly assigned. And the neat thing about random assignment is it tends, especially with larger samples, to basically even out all of the individual differences between groups. So all the individual differences are there, it's just that the groups themselves start to become very similar. So what happens if you use random assignment, and instead of manipulating something, so again, we get 100 people, we use random assignment, 50 of them go in one room, 50 of them go to the other, and then we don't do anything other than measure their performance. More often than not, in fact, a very large percentage of the time, there would be no difference between those two groups. They're not going to differ. And this has been tested over and over and over again, which means that when you use random assignment, you can be pretty confident that anything that you measured between those two groups would be very similar unless it's differing because of something that you're going to do to those groups of people, some condition or some treatment or implementation. So when we have an experimental method, causality can be inferred. So if we can make a strong argument, the only thing that changed between these two groups was the type of music they listened to. I found a difference in performance. Music caused that difference. Again, the generalizability is fairly questionable there, though, because you have so much control. You controlled exactly what type of music they listened to, how they listened to it, how they were assigned to rooms. They knew they were in an experiment. So a lot of times it's harder to make an argument that it would generalize to different groups of people. So an example, what is the effects of incentive on attendance? So we could set this up even in a field study. If we had a class where everyone was attending the same class, they were always going to the same time, same room, same professor. But the professor had secretly randomly determined each person was given a different instruction on what incentive there was for attendance. So a third of the class was told there was no incentive for attendance, just attend or not attend, it's up to them. A third of the class was told if you make every single class, you'll get 25 points added to your score at the end of the semester. And the other third was told if you miss more than 3 days, you'll actually lose a letter grade in this class. Now, as long as those students didn't talk to each other about the conditions they were in, which if they had would be a potential confound, if you actually find a difference in those levels of attendance, you can make a pretty strong argument that different types of attendance plans does affect attendance. So of the three types, we've been only talking about experimental. The other two types, quasi-experimental, generally speaking, looks very similar to an experimental design. It's just missing the random assignment. And a lot of times what we're going to find in organizations is quasi-experimental is the kinds of studies we can do because we're not going to be able to do random assignment. We're not going to get an organization that's going to let us randomly select who goes into various conditions. More often than not, we're going to find an organization that says, we'll let you try your new intervention in our McDonald's on Smith Street, but we're not going to let you do it at the McDonald's at this other location, and then you can just compare the two models. Now, the problem there is we're losing internal validity. If you find that those two McDonald's are fairly similar in performance to begin with, and then you intervene with a new management plan at one of them, and then that one starts to make more money, you've got a pretty good argument. It's probably our management plan, but other things could have happened. Maybe just more and more people found out about that McDonald's during that time. Maybe the other McDonald's had kind of a health scare and people stopped going to it. There's other possible explanations for what you found. And finally, non-experimental basically means not only do you not have random assignment, there really is no control whatsoever. You're just observing behavior without intervening or basically messing with it. So methods of data collection. There's two broad types. We're going to talk about both. Quantitative methods are generally preferred in IO psychology. They rely on tests, rating scales, questionnaires, psychological measures, physiological measures, and they yield results in terms of numbers. So quantitative, a quantity is a number. So quantitative methods are methods that use numbers. They try to quantify human behavior, they try to quantify people, they try to quantify environment, and then they look for patterns. And it's these quantitative methods that we can use statistical analysis with. They're often referred to as more objective, in that, again, if we're actually measuring something physiological, it's fairly objective. Objective just means that multiple raters would all agree on the score. So if someone was measuring my height, and they were all using the same ruler, they would probably all come up with the exact same height. That would be an objective measure of height. But if someone was watching my performance in a boxing match on a 1 to 10 scale, there might be some disagreement. That's probably more of a subjective. So objective and subjective is more defined by how much disagreement there is in the measurement. The less disagreement that multiple people would have in how it was measured and what number was determined, the more objective it is. And there's a lot of focus on IO psychology of trying to come up with these more objective measures. So, when we're doing measurement, we're wanting to come up with these quantitative numbers, so quantitative measurement, and what we're trying to measure is basically constructs or attributes. We're trying to measure job satisfaction. We're trying to measure performance. We're trying to measure personality, conscientiousness. So when we're looking at this, one of the things we want to test for is reliability. So how reliable is our measure of this construct? And reliability simply means that if we measure the construct, let's just stick with job satisfaction. If someone has high job satisfaction, if we gave them a job satisfaction test and they scored highly on it, we'd expect them to probably be just as satisfied a week or two later. We wouldn't expect it to constantly be changing. Unless there was something major going on in the organization. So one of the ways we can test for reliability is simply test or retest. In other words, we give someone a test of conscientiousness or job satisfaction, and 2 weeks later we give them the same test and see how closely their scores match. If they match well, we say that test is fairly reliable. Reliability can also be measured through parallel forms. Basically, again, we can come up with a giant pool of items that it's meant to measure job satisfaction. And if we give someone 10 items from that pool 1 week and 10 other items the next week, we'd expect, again, if all those items measure job satisfaction, for their scores to be very similar. A lot of times, if we're looking at people giving scores, so we have managers rating someone's performance on a 1 to 5, we'll often look at inter-rater reliability. So this is, again, often done in sports that require judging. You'll have multiple judges, and the question is how much are those judges agreeing? The more they agree, the higher the inter-rater reliability. The less they agree, the lower that reliability. And finally, we can also just look at internal consistency. So if we're measuring a construct with multiple questions, so if we have 5 items that are all supposed to measure job satisfaction, we'd expect all 5 of those items to be highly correlated. If you were unsatisfied, they should all be low. If you were highly satisfied, they should all be high. So one of the steps in scientific methodology is that if we're using quantitative methods, we need to make sure that what we're measuring, we're actually measuring reliably. The next thing we want to look at is construct validity. Construct validity is, now that we know that we're reliably measuring it, are we actually measuring what we think we're measuring? And there's 2 kind of ways we can do this, content or criterion. Content validity for construct validity just means that we're looking at the questions and asking logical questions. Does it look like we're measuring what we think we're measuring? Do these 5 items actually look to people like they actually are measuring job satisfaction? Criterion-related construct validity means we're going to go one step further, and we're going to statistically test this measure of job satisfaction against things that we would expect it to be related to. And there's kind of 2 ways we can do this. So criterion-related validity is the statistical testing of whether a measure is related to things that would logically it should be related to. So there's basically 2 ways we can do this. We can do it predictive or concurrently. Concurrently means we just measure everything at the same time. We measure it concurrently. So, for instance, if we were wanting to validate a job satisfaction measure, we could give our job satisfaction measure to 100 people. We could also ask them how committed they are to their organization. We could also ask them how often they're late to their organization. And we could also ask them how likely is it that they're going to leave their organization in the next 6 months. All three of those extra things beyond job satisfaction are things we'd expect to be highly related with job satisfaction. So then we look, are they related? If so, we would say that's an argument for criterion-related validity. The other way we can do this is predictive validity. In this case, we would measure job satisfaction at time 1. And then we would wait 6 months and find out, are the people that were highly satisfied still with the organization? During those 6 months, how often did they actually show up late? And during those 6 months, how often were they loyal to their organization? So the only difference between predictive and concurrent is concurrent validity, we're collecting all the data at one time. Predictive validity, we're collecting the data over a period of time. Predictive data usually is more trustable, and it's a better way to actually get at validity, but it also takes more time and is more costly. We can also look at criterion-related validity on the question of whether it's convergent or divergent validity. So all the examples I've given so far for predictive and concurrent validity are what we'd call convergent validity. I'm comparing my measure of job satisfaction to other variables that job satisfaction should be related to. And you can even compare it to previous measures of job satisfaction. Divergent validity means that I'm also going to measure things that job satisfaction shouldn't be related to. So for instance, I wouldn't expect job satisfaction to necessarily be related to counter workplace behaviors, and maybe it would be, but also maybe personality traits. Maybe I would, make an argument that if you're conscientious or not shouldn't matter with whether your job have high or low job satisfaction. If you have a high openness to experience, that shouldn't necessarily be related to job satisfaction. So in other words, another way to relate the validity of a measure is to find out that it's not related to things that it shouldn't be related to. The other way we can collect data is qualitative methods. So this is basically any time we're collecting data that can't be put to numbers. It includes procedures like observations, interviews, case studies, and analysis of archival written documents. Generally, what we gather with this is detailed, rich, verbal information. And generally, we're not going to do statistical analysis for this, but we are going to still be able to look for patterns. We're still going to be able to use scientific methodology with this kind of data. We can look for how it describes and how it predicts and how it relates to each other. But instead of using statistics and analysis and numbers, we're often going to use flow diagrams, narrative descriptions of the events and processes. It's often viewed as subjective, because again, the interpretation of qualitative data can change from person to person. Each person in this class could read a statement someone made about their feelings towards work. I generally really like my work, but sometimes it gets me down a bit and it can be frustrating at times. Different people might read that sentence and come to different conclusions. Some people might focus on well, generally I like my job, and say, well, this person's clearly satisfied with their work. Other people might focus on the negatives and go, no, actually, I think this person isn't happy with their job at all. And that's the subjective nature of qualitative collection. So qualitative and quantitative research are not mutually exclusive. In fact, there is a strong presence or a strong force in IO psychology suggesting that really you want to use both. It's great to collect quantitative information because it allows statistical analysis. It allows techniques to make an argument towards internal and external validity. We can test the reliability of the measures. We can look at the actual construct validity of those measures. We can look for statistical patterns. And if we find those patterns, we can even estimate the likelihood that we would find those patterns in other samples, which even gets to external validity. But a lot of times those numbers lose a lot of detail. So saying someone has a 7 on a 10-point scale of job satisfaction lets us compare them to other people's levels of job satisfaction, but it doesn't give us a good feel for what exactly a 7 is. Qualitative research adds on to that by giving us verbal descriptions of what that person's experience was like. So a lot of IO psychology is focused on the idea now of triangulation, examining converging information from different sources, using both qualitative and quantitative research when you're asking questions. So generating a hypothesis from a theory, and those hypotheses being both qualitative and quantitative in the same study. So there's a strong presence in IO psychology to focus on the idea of multiple measures using multiple methods in order to really get at the constructs we're interested in.